My name is Brad Green. I'm the Eng manager for the Angular team, and I really thank you for all coming out tonight. I know it's a nice rainy night, and you probably had better things to do, but you came to join us, so we're really excited you came. Couple announcements that we normally do in the Angular team just to get some of the things that we've been doing in one place for you. So number one of our big partners in Ionic, they've reached beta, and this is something we've been working with them on throughout the whole Angular 2 process, is making sure that the Ionic team can join us and responding to their feedback and making Angular work really well for them. So we're super excited that they've come along and they're at the beta stage as of this week, I think, along with us. You can find out more about it on the Ionic blog where they talk about it, and you can start to get using it over there. Number two, we've been working with the TC39 committee on the future of the JavaScript language in a couple of places. So number one, we've been using this feature called zones. And if in Angular 1 you were tired of calling apply in various places, then this is the nice answer in Angular 2 why you no longer need to do this when you want to synchronize with external code. So zones gives us the great capability. We brought it to the JavaScript committee as a way to solve other problems that other frameworks have. We've got a lot of interest in collaboration for folks in Ember and React and other frameworks. So we're excited as this being some nice underpinnings for the future of how we manage the VM turns in JavaScript in the future. Other things we've been working on with TC39, we've been partnering with folks on the Ember team on the decorators end of things, and we've now gotten to stage 0, which is the very first stage, but we have good hopes this will go well, on the method parameter and function expression decorators. What this would mean to you is if you're a fan of ES6 and Babel compilation versus wanting to go the TypeScript route, this means that we'll be able to do the same sort of nice annotations for ES6 code that we can do in TypeScript right now. It's currently missing in the ES6 thing, but we'll be there soon. Last thing, we're going to be a bunch of other places this year, and we wanted you folks to join us. And so if you go to the angular.io site, we have a list of events that we're going to be at, and so that you can follow along. One of the next ones we're going to be at is at the Fluent conference in San Francisco. I'm going to be talking, and a couple of our other Angular team members are talking there. There's a ton of events we're going to be at throughout the year across the world. Please come join us. And with that, I'd like to give the mic over to Tracy, and I did that because she just put a bite of food in her mouth with a couple more announcements. Here you go, Tracy.
Thank you. Hi, guys. My name's Tracy. I run the Modern Web event. We're actually more than just a meetup. We have a lot of really cool online content, and we're super excited to do this with the Angular team. So a couple upcoming events that we'd love to have you at. March 16th, we have the Polymer. We're partnering with the Polymer team, so a lot of people on the Polymer team are going to be talking if you want to figure out what's happening with web components in 2016. And we're also doing a partial hack night as well. So that'll be really fun to just sort of have the Polymer team there while you guys are hacking. Please do come. It'll be at Google as well. And then March 19th, we're having our first online conference. And that's going to be ES6 modules with Kent Dodds, who does Angular Error and JavaScript Error, and then Mastering Chrome Developer Tools with John Cooperman from Twitter. Couple new releases that we just have on our website. We just released the Jeff Cross show with Jafar Hussain for Falcor.js. Some of the stickers I was passing out. Yeah, it's really amazing. And then we also just released a podcast with Matt Beal, who's one of the Ember Core team members, on MobileDoc, which is a project he's been working on pretty significantly, Tori, and then the future of Ember.js, what's happening in 2016 there. So with that, love to... Can I show the... Yeah, of course.
Jafar couldn't be here tonight, but he wanted me to show a commercial that he made for Angular 2. From the Jeff Cross show.
I would say that Angular 2 is really exciting new models for UI development, and I'm very excited. I do like Angular 2. I think it's a fantastic framework. Angular 2 is really exciting new models for UI development, and I'm very excited. I do like Angular 2. I think it's a fantastic framework. Angular 2 is really exciting new models for UI development, and I'm very excited. I do like Angular 2. I think it's a fantastic framework. Angular 2 is really exciting. New models for UI development, and I'm very excited. I do like Angular 2. I think it's a fantastic framework. Super excited about it.
Well, that's our show. Thanks for watching. Good night.
Thank you, Jaffer, for sending that for us. And now we'll welcome Victor and Kara to talk about Angular 2 Beta.
Hi, everyone. I'm Kara Erickson, and this is Victor Savkin. And in this talk, we're going to give a high-level overview of Angular 2 by drilling down on 3 core concepts: components, dependency injection, and change detection. To do so, we'll be using a simple application as an example. You may have seen this app before if you read Victor's blog. It's a basic app that organizes your tech talks and lets you browse, filter, watch, and rate them. We'll be using TypeScript for these examples. You can also use ES6, ES5, CoffeeScript, or any other flavor of JavaScript you want to write Angular 2 code, but we'll be using TypeScript because it allows us to leverage ES7 decorators and some other stuff that we'll discuss later. So let's jump in. First, we'll discuss components because components are the primary building blocks of Angular 2 applications. Every Angular 2 app is simply a tree of components, with an application component at the root that contains all of the other components. So if we take a look at our example app architecture, we have the application component at the root. We have a component for our list of talks, and our talks component is made up of a number of individual talk components. This emphasis on component-based architecture helps promote reusability and modularity in your application. So when you model your app this way, it's easy to keep track of how different parts of it interact. So we've been talking a lot about components. What exactly are components? Components are just directives. Specifically, a component is a particular class of directive that contains its own view. By this definition, components already existed in Angular 1, but it was such a common pattern that Angular 2 provides support for them as their own explicit entities. In addition, Angular 2 has given components a number of upgrades. In this section, we'll review some of the improvements that components have gotten, such as a simpler definition, a well-defined API in the form of inputs and outputs, intuitive lifecycle hooks, easy interaction with the host element, and a self-describing nature. So first, we're going to talk about the component definition. So here we have the definition for our talk component, which is, if you remember, a component that displays an individual UI for a talk. The definition consists of 2 parts. The first is the component class. This is just an ES6 or TypeScript class that contains the state and behavior of the component. So here we have a property called talk that we expect to be of type talk, and we have a rate event. The second is the component decorator. If you haven't seen decorators before, don't worry, it's not in JavaScript yet, but it's simply a function that modifies the class or property that it precedes. So in this case, our talk component is being decorated with the component decorator. And just like normal functions, you can pass any parameters you want into a decorator. So in this case, we're passing all the metadata the component needs to be processed by Angular. So the CSS selector that identifies the component in the DOM, the URL of the template, and any directives that we're going to be using in the template. So in this way, you can see that Angular 2 is doing a great job of separating concerns. If you remember the DDO from Angular 1, it was kind of a kitchen sink of metadata and lifecycle hooks and toggles. And Angular 2 really simplifies it so that you have all of your metadata in the decorator and you have all the public API and behavior in the actual class. So looking at its configuration, you may have also noticed that it's now necessary to declare any directives you're going to use up front in the configuration. So it is more to type, but it's important to remember that it allows you to be more explicit about which directives you can use in your view. So if you were using 2 libraries that define a directive of the same name, you could explicitly import the one that you want to use. In Angular 1, you'd kind of be stuck with both, and both directives would run, which would probably cause some weird behavior. Okay, so let's take a look at the components template. As you can see, you can still interpolate bindings into the view with the curly brace syntax. In Angular 1, these properties would have to be on the injected scope, or if you're using controller as syntax, it'd have to be on the controller. But Angular 2 doesn't require any intermediate layers. Talk is simply a property belonging to the component class, and any property on your class is automatically available to be interpolated into your view. Now that we've discussed some basics of component definition, let's move on to how the component interacts with its environment. In Angular 2, components have well-defined inputs and outputs, which together form the public API of the component. As you might imagine, information flows in through inputs and flows out through outputs. More specifically, inputs are passed in through property bindings and outputs are produced using events. So taking a step back, what's a property binding? To understand, let's start with a property binding on a native HTML element like a button. Let's say you want to programmatically change the button's disabled state. Angular allows you to bind to the button's native disabled property by wrapping it in square brackets. In other words, whenever the view is checked, the wrapped property on the left is set to the result of the template expression to the right. So when it's true, the disabled property will be set to true and the disabled state will appear, and vice versa. In addition to binding properties, you can also subscribe to events. You can do this by using parentheses syntax. So the button natively emits a click event when clicked, so you simply wrap click in parentheses, and when the click fires, the submit function will be called. So returning to our talk component example, how can we use those inputs and outputs to interact with the component? Well, the talk component is simply formatting UIs, but you actually need to pass the talk data in for it to work. So if the data is stored in something called my talk, let's say, we can create a property binding to our component's talk property by wrapping it in square brackets and setting it equal to my talk. And then when the view is checked, my talk will be evaluated, and then it will be passed in as the talk property of talk component. It's important to note that if the talk property changes from within the component, like if there's an input maybe or something like that, this doesn't affect the my talk variable up top. It's a one-way binding, not a two-way binding, and this can really jump out at you if you don't remember. So if we want to propagate information out of the component, you have to remember to emit an event. So one way talk data might change is if it's rated from within the talk. So when this happens, we can emit a rate event. So if we wanted to listen to the rate event, you just wrap it in parentheses and set it to whatever expression you want to run. So here the rate event is called, and then on rate fires. Okay, so there's still some stuff that we have to do in the class to make this all work. So all we have to do is declare our expected inputs and outputs. So we can do this by adding the input decorator to our talk property. This sets up the talk property as something that the user of the component can bind to. Similarly, we want to add an output decorator to our rate event. This makes it externally subscribable. So why require these annotations at all? Well, for a few reasons. So first, we may not want to make all of our class's properties and events publicly available for user bindings and subscriptions. Let's say we had a private property that requires some processing. We wouldn't want the user to be able to accidentally subscribe to the unprocessed version and cause a lot of problems. If you explicitly call out which inputs and outputs are public, you can make it clear what you expect to be used and set people up for success. Looking at this definition, it's pretty clear what the public API is. This is good for humans, but it's also great for tooling. Second, because we know these inputs statically up front, we can use them to generate faster code. And in any case, we can see it's still much clearer than the cryptic scope object syntax from Angular 1 with the @ and the equal sign and the ampersand. What does that mean? So when you think about this in terms of your broader application architecture, all you have to remember is that children or parents pass data down to the children through property bindings, and children propagate events back up to their parents. Okay. Components also have an intuitive lifecycle that's pretty easy to tap into. You can be notified when a component's being created, when its properties change, when its children are checked, and when it's being destroyed. In Angular 1, there were also lifecycle hooks, but there was some implicit complexity when you were using them. So you had to be pretty familiar with Angular internals to puzzle out where your logic should go. If you wanted to make sure that the view for your component had already been initialized, you'd have to be aware of compilation and linking order. For instance, that children are linked before parents, or parents are compiled before children, and so on and so forth. These new lifecycle hooks are way friendlier and clearer. You don't have to know the implementation details to use them. If you want to ensure that the view has been initialized, simply use after view init. That's it. So to leverage any of these lifecycle events, you simply need to add it to your class as a method, prefixing the event name with ng. So after view init becomes ng after view init, and it will be called at the appropriate time. If you're using TypeScript, we also recommend implementing the matching interface, which Angular provides, but it's optional. It'll just give you some additional IDE support. Better lifecycle hooks allow you to do some cool things. For example, you can easily subscribe to changes to your component with the onChanges hook. In Angular 1, you'd have to create a scope.watch for every property that you cared about, and you'd have to check whether values had changed. Now you can simply subscribe and receive a collection of changes. And another thing that's easier in Angular 2 is interacting with the component's host element. A host element is whatever element the Angular component is associated with in the DOM. A component can listen to its host event with a host listener, and it can update its properties with host bindings. This is pretty powerful. Here, the component can listen to the host's input event using host listeners, trim the new value, and since that value is bound to the input's value will also be trimmed, which is pretty cool. Beyond the syntactic sugar, it's important to understand that we're not manipulating the DOM directly with host bindings or host listeners. Angular2 is providing a higher level API. This is useful for a couple of reasons. So it allows unit testing most of the behavior of the application without touching the DOM, which tends to be faster. And more importantly, it allows running Angular applications and things like web workers and outside of the browser completely. Sometimes you will need to interact with the DOM directly, so Angular2 does provide those APIs, but the hope is that you'll rarely need to use them. So we've seen that a component knows how to interact with its host element. It knows how to render itself. And in a moment, Victor will explain how it configures dependency injection. All of these characteristics make components in Angular2 self-describing, which means that their annotations contain all the information required to instantiate them. This is important because it allows us to treat any component as an application. You can bootstrap any component, and it does not have to be special in any way to do so. Consequently, there's less API to learn, and it makes components more reusable and composable. So in summary, you can see that components in Angular2 are pretty cool. There is some new syntax, but they're generally more explicit, organized, and intuitive to work with. So I'll hand it over to Victor now.
Thank you. All right, so let's switch gears a little bit and talk about another important part of Angular, which is dependency injection. Okay, so the idea behind DI is very simple. So if you have a component that depends on a service, you don't want to create the service yourself in the constructor of the component. Instead, you want to inject it or declare your dependency on the service in the constructor, and the framework will give you one. This allows you to depend on interfaces and abstractions rather than concrete classes and functions, which enables more testability and in general makes your code more decoupled and provides a lot of nice properties. Let's see how it can be used. So we have a component here that just renders a list of talks. And here it's template. So let's mock up a simple service that will provide us the data needed to render the component. How can we use this service? One way to do it is to directly instantiate it in the constructor of this component, as shown on the slide. So this is fine for a demo app. That works fine for demo apps, but it's problematic if you write a real application. Because in a real application, the backend object, what it will do, it will probably fetch some data from the backend. So it will make real HTTP requests, which means that if you write a unit test for this component, the unit test will make a real HTTP request, which is not a good idea. So we have this problem because we couple this component to this backend object. And we can fix it by injecting the backend object instead. So that seems like a small change, but it's a very significant one. So we added a great deal of flexibility to this component. Now this component can work with any object that sort of satisfies the same interface as the backend. So we decoupled our component from the concrete implementation of this service. This means that we can pass a mock version of this service if we want to when we test this component. The very last thing that we need to do to make this example work is to tell Angular how to create an instance of the backend. And we can do it by adding the provider's property to the component. We either have to add it to the talk list component itself or to its ancestor. So if you prefer, for example, to write your applications in Angular 1 style, what you can do, you can register all your providers in one place in the root component. And it will make them available for every component in the system, like in Angular 1. It is important to understand one property here, and it is that there is a difference between declaring a provider and injecting an object. For example, on this slide, you can see how application declares the provider, but talk list injects that object. So you declare a provider in the component's decorator, but you declare a dependency on an object in the component's constructor. And understanding this is very important. So those two things are distinct. So this slide shows sort of Angular 1 way of doing things. When you put everything at the root component, and everything becomes available for every component in the system. But the DI system in Angular 2 is actually a lot more flexible, and I will show you a few examples. For example, here I declare some provider in the talk list component, and on the right you can see the place in the component tree where it happens. By placing the provider there, I tell Angular to do the following things. First, I tell Angular to create an object when the talk list component is created. So the talk context object will be created to be the component. Second, I tell Angular to make that object unavailable once the component is destroyed. Third, I tell Angular to make that object available for injection for the talklist component itself and know its children. But you cannot inject that object into other components. For example, the filters component won't be able to get access to talk context. And finally, all the children and the talklist component itself will have access to the same object. So there will be only one talk context created here. If I move the provider down to the talk component, then if I do that, then every talk component, every instance of the talk component class will get its own instance of talk context. So where you place the provider is very important. It defines its visibility, and it also defines its lifespan. So a good way to think about it is that every provider is defined and placed on the same DOM element as the component. So it matches your DOM. All right, so both Angular 1 and Angular 2 come with dependency injection. But in Angular 1, we had several APIs to configure DI or to use DI. For example, if you want to inject the directives element, you do it by position by passing it into the link function. If you want to inject a service, you do it by name. So it was very confusing. Lots of APIs. It wasn't consistent. So Angular 2 provides a single consistent API for injecting all the dependencies. All of them are injected in the components constructor. For example, here, the component injects two things. It injects the backend, which is likely to be a singleton, and it also injects an element ref, which is unique for every component. So we use the same API to inject both global and local dependencies into the component. Moreover, a component can inject other components using the same API. Finally, I want to say a few words about the last DI-related thing, which is modules. So in Angular 1, what you could do, you could define a module that would contain filters, services, and directives. Since ES6 modules right now are widely available, we decided to use ES6 modules instead of our custom, like handmade module system. And I will show you how we can do it right now in Angular 2. So what you do right now, instead of defining this Angular 1 module, you define an ES6 module, a standard ES6 module, and you just export an array of providers. Then in your application, what you do is you include that array into the array of providers of the component. So basically, just a convention. There is no Angular-specific code here. It's just plain JavaScript. And you can do the same thing with directives. Finally, as you probably noticed, we don't use strings anymore for dependency injection. Instead, by default, we use types. And this has a lot of upsides. First of all, it's minification friendly, so you don't need to worry about that. Second of all, you cannot have name collisions, which is important if you have lots of libraries contributing to the same DI context. But it has one downside, and it's an important downside, and it is that some bidirectional dependencies has to be handled in a special way. For example, here, the code on this slide won't actually work. The reason is the child component class hasn't been defined yet when the viewChild decorator executes. I think in general, you should avoid bidirectional dependencies because they make your code harder to understand and harder to refactor. And in Angular 2, we actually made an effort and designed our API so you can write your code without having bidirectional dependencies. But if you absolutely must have them, then we provide a primitive that makes this situation possible. It's called a forward ref. So what you do is you wrap your reference to a component class into a forward ref, and then Angular will execute that function later when the child component class is defined. So it works, but not very pretty. So to sum up, I think DI, or dependency injection, is one of those features that you don't see the value of right away, but the bigger your application gets, the more value you get out of it. Because it allows you to depend on interfaces rather than concrete classes and functions, which is important. This results in decoupled code. So you have code that you can swap different parts of your code without any problems, which improves the stability. So in Angular 2, we simplified our DI API quite a bit. So instead of having multiple APIs, we have only one and it's consistent. And we also made it more expressive and more powerful. Finally, I want to say just a few words about how we execute template bindings and how Angular propagates changes through a component tree. Here, what's important is not the API, because there is hardly any, but sort of the idea, the mental model. So what I want to do right now is to give you sort of an intuition of how it works. So once again, we're going to look at the same application. And in addition to the component tree, we're going to define a model with the state of the application, because most applications will have some sort of model. Let's say that our model is what you see on the left. Now imagine some change happens, an event happens. Let's say I decided to change the rating of that model. So what will happen at this point is, when the event handler is done executing, Angular will walk the component tree, and it will update the component tree based on the model. So in this particular example, this component will be updated. Then it will update the DOM to match the state of the component tree. And once again, in this example, this chunk of the DOM will be updated. Or more abstractly, Angular syncs up the component tree with the model, and then the DOM with the component tree. And the direction of the arrows here is very important, it's crucial. The fact that all arrows point in the same direction allowed us to make Angular2 a lot faster. It's a lot easier to debug. It can run in a web worker and do lots of other great things. So if you want to have a good time with Angular2, you must adhere to this model. Like, I highly recommend you do that. If you start doing something else, for example, you decide to keep your state in the DOM and treat that as a source of truth, and essentially reverse into errors, your dev experience will degrade. So this is a new Angular2 model. All right, so if you want to learn more about Angular2, there are a few resources I can recommend. First of all, you can go to Angular.io and read wonderful guides and API docs that we have. Like, we have a lot of information here, and you should go there first. Then, I mean, it's shameless self-promotion, you can go to my blog and give me more traffic, which is important. And you can also follow Kara or me on Twitter. Thank you.
Ben Lesh.
I will try this. This is what I was doing right before I came here. This is just a shout out. It's my daughter's first birthday today, so I took some time off of work. That's Lily. She had a really good time with the frosting. So who am I? I think I might have accidentally deleted a slide there, but my name is Ben Lesh. I work at Netflix on the Edge developer experience team with Jay Phelps here with the purple hair. He looks lovely. I'm also the project lead in RxJS 5. And OJ Kwan is here somewhere. I saw him earlier. He is a collaborator with me, and I'm really excited to see him here. He's way in the back, so you don't have to bother me with RxJS questions. Get that guy. That's why I'm excited he's here. No, ask me questions. I love it. So I need to do a quick recap on observables to talk about operators and merge strategies. RxJS 5, or RxJS in general, is all about observables. So quick recap. An observable is a collection of things, collection of any number of values over any amount of time. It's an async abstraction similar to a promise. It's lazy, so it waits for you to subscribe to it before it starts giving you values, unlike a promise, which is it's already active by the time you have it. And it's cancelable, so when you subscribe to it, you get back some cancellation semantic that allows you to say, I don't care about this anymore, I want to throw it out. Another way to think about it is they're streams. Like, a lot of people say, oh, these are streams. I've got bad news for you. Observables are not streams, okay? Observables create streams. This is an important distinction I want people to make. The observable itself is kind of an inert thing until you subscribe to it. So observables are just functions. This is what they really are. People try to draw comparisons to promises a lot or whatever. I want to kind of get that out of people's heads. Observables are just functions that tie a producer to a consumer. So they tie some observable or some observer that you're giving it to some arbitrary producer and give you back some cancellation semantic. So to prove it, I've written this observable, which is just a function. So hopefully everybody can see this okay. This is an interval function that will act just like an observable. It's going to give me an interval every 1 second. It's going to give me a new value. And how does it work? It's a function that takes an observer. The observer is just a simple object with a next method on it that you can pump a value into. And you see inside of that, I'm setting up an interval with set interval. I think most people with JavaScript are familiar with that. And then it returns a function that calls clear interval when you call it. So that'll stop that interval from happening and stop it from pumping values into my observer. So what does this look like when I use it? Well, when I use it, I just pass in any old object with a next method on it. That's an observer. Commonly in RxJS, you'll see functions go in there, but here, those functions get scrubbed into observer. So this is the more basic example. And then it gives me back some subscribe function I can call later to cancel things. If I wanted to turn this into an observable, all I really do is just wrap that function in new observable. So I pass that same exact function to my observable constructor. Then I call subscribe on interval because it's not a function anymore. It's an observable. And then I call unsubscribe on the subscription object I get back. So you might be asking yourself, well, if I can write an observable as a function, which is really simple, why do I need this whole class, this whole type to wrap it in? There's a variety of reasons. I'll get to that in a minute, but first let's talk about operators, because that's what this talk is really about. What is an operator? It transforms streams into new streams. You subscribe to a source stream, you transform the values in some way, and you emit those values on the returned stream that your operator creates, right? That's all you do. So operators are really just functions also. So this is going to be a trend you see. So they return an observable that subscribes to the source observable. And generally they join their subscriptions. Well, I already told you that observables are just functions. So if we were to expand this, this text here, it reads like this. Operators are just functions. They return a function that takes an observer and returns a cancellation function that calls another function and takes an observer and returns a cancellation function. So operators as functions. So this, I'm going to take my function observable that's not the class observable, and I'm going to write an operator for it that's also just a function. And here it is, map. Everybody's familiar with what map does. This would do the same thing that if you mapped an array, that sort of thing. And what this is going to do is it's going to take a source, and the source is my observable function that I need to pass an observer to at some point. And it's going to return, you see it returns a function that takes an observer. So we know a function that takes an observer is an observable, right? And inside of that, when you call that function, it's going to call the source function. So it's going to subscribe to that previous observable, that source observable, and it's creating its own observer. So when it creates its own observer, it's actually wrapping the observer you gave it, and it's calling that projection, that mapping function that you pass to it on the value, and then passing that through to the observer that you gave it. So really, what operators are actually doing, when you subscribe, the operators go through and they create observers for the source observable that was there, and the observer itself does the logic. In this case, the observer is doing the work of applying that projection and then handing it off. So really what you're doing when you chain a bunch of operators together is you're not chaining observables together, you're really chaining observers together. So you call subscribe, it builds out this chain of observers that then hands values from one place to the next. So if I was going to use this, it would look like this. I'm going to use that same interval function I showed earlier in the talk, and I'm going to pass it to map and pass my mapping function. It's going to return me a mapped function. I can then call that with an observer that's going to log it out to console, and I get back an unsubscribe function. So it works exactly the same way that the other observable function did. Well, it's not entirely useful. So let's look at what an operator function would look like if it was operating over observable. Not a lot different. Again, I'm just wrapping that function in new observable. And of course, source is an observable now, so I need to call subscribe on it. When I go to use it, it looks exactly the same as it did before, but I'm getting a mapped observable back now instead of a function, which means I have to call subscribe on it, and I get back a subscription object. So this is fine. This is fine. We could use this all the time, right? The problem is, what happens when I want to chain map together twice? You see, it jumps to like, oh, okay, every operator I chain together now, it's going to grow in both directions. It's going to get really gross and sort of lispy, right? Wouldn't it be better if it looked like this? If I was able to say interval.map and kind of chain them left to right so it was easier to read. It's easy enough. We have this observable object, right? What if we just stuck map on its prototype? And of course, if map's on its prototype, source doesn't matter anymore. We don't have to pass source in. Source is this now. And that's it. This is a primary reason. There's other reasons, but this is the primary reason that observable, even though it can just be a function, is an object, right? So all of this is just functions. The class is there to kind of tie these functions together. Here's a list of common operators. So map I just went over. Filter, reduce, and scan are all very similar. Map, filter, and reduce are just like you'd see on an array. Scan is like reduce, only it emits the value every time. But these other ones that are listed in here are really important. I'm going to talk about 3 of them, really 6 of them, but there's 3 strategies in here. Merge, concat, and switch. But first, I want to go back to map really quick because I want to introduce you to this ASCII art up here. This is called a marble diagram. We use these actually to write integration tests for RxJS 5. This is something that I'm planning on releasing very soon. You can already kind of do it, but it's not very ergonomic right now. So I want an ergonomic way for the public to write integration tests for things that consume observables. And what this is these are ASCII art representations of a timeline where events occur. So each one of these dashes is a moment in time where you've subscribed to the observable, but nothing has happened. And then when you see a value, that means an observable has emitted a value. Now, the nice thing is you can see I subscribe to my mapped observable, and I'm showing that it's subscribed to the source above it. And it vertically aligns. And that's a moment in time where when source emits 1, my mapped observable will emit 2. All right, so again, when it emits 2, I get 4, and so on, because it's getting applied through my mapping function. And when you see a pipe, that means the observable we've unsubscribed from that subscription. Okay, so this is basically what map would look like with a marble diagram. So that was easy because we're just going mapping from value to value. But what happens when you want to do something, you want to map a value to some asynchronous action? Like I get some value from an event off of an input or something like that, and I want to send an AJAX request, something asynchronous. So I'm going to wrap that in my favorite async type. I'm going to wrap it in observable. So let's just assume that HTTP GET here returns an observable. And what do I have then? I've got an observable of observables. Well, that's not terribly useful. If I subscribe to that, and I log it out, I'm just going to see object, 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 object over and over again in the console. That's not useful to me at all. What I really would like is I'd like a way to get the values out of that observable and merge it back into my stream, to join it into my stream so I can emit those, because that's what I care about. So for that, we have merging strategies. And the 3 basic ones I'm going to try to talk about tonight are right here: merge, concat, and switch. These are the ones that you use the most often. There are other strategies, but these are easily the most important. The first one I'll talk about is probably the easiest to wrap your head around. This one's MergeAll. MergeAll is an operator that operates on an observable of observables. So again, this is an observable that says, here's an observable, here's an observable, and it's the result of something like my mapping function that you saw, where I mapped a value to some AJAX request, let's say. And I'm going to use these marble diagrams to go through it. So when I subscribe to the result, it also subscribes to the source. When the source gives me the first observable A, I subscribe to it immediately. And then when observable A gives me a value, I forward it along to the result. When the source gives me observable B, I subscribe to it immediately. You can see in parallel, I'm subscribed to 2 observables now. A gives me a value, I forward it to the result. B gives me a value, I forward it. Source gives me observable C, I subscribe to it. A gives me a value, I forward it. B gives me a value, I forward it. A stops. The reason result didn't stop there is because the source hasn't stopped yet. You see the source's pipe for when it ends is further down. Then C gives me a value, I forward it. I get observable D from the source, I subscribe to it. B gives me a value, I forward it. B ends, I'm still not done. D gives me a value, I forward it. C. D ends, I'm still not done because the source is still not complete. But then the source completes, my result isn't done. The reason my result isn't done is because it was not done with C. So merge effectively is a strategy. It'll subscribe to all observables that you give it immediately as it gets it and take all of their values and merge it into the output, into the result. and it will not complete until all of those observables complete and your source completes. So that's merge. It's kind of the naive, just give me everything. Next up, we have CanCat all. So what this is going to do is pretty much what it sounds like. It's going to take every observable it gets, and it's going to concatenate them, which means to place them kind of end to end. So just to step through this, when I subscribe to the results, it subscribes to the source. Source gives me observable A, and then it immediately subscribes to it because it hasn't subscribed to anything yet. It has nothing that it's subscribed to. It can do one at a time. A gives me a value, I forward it, but then I get observable B, and you notice I don't subscribe to it yet. It's actually going to be queued up. So this is something that you have to be careful with CanCat. If you're concatenating multiple observables and one of them happens to not end, and then you get like a million more, then all a million of those are going to be sitting in an array in memory. So you need to be a little careful with this one and know what you're merging. A gives me all of its values. The source ends, but we're not done because I still have both A and B to finish. A finishes now, great. Toss that aside and I can subscribe to B. B gives me all of its values, and since it's the last observable I've gotten from the now terminated source observable, I can complete. So all CanCat does is it says, yeah, give me all of these observables that I've gotten so far, and I'll queue them up and make sure they all get executed and their results are placed end to end. So it also, again, will not complete until all child observables complete and the source observable itself completes. So that's, again, something to be careful of is if you're concatenating in and one of them happens to be something that's really long running or just doesn't complete. All right, this one's actually the biggest one. This one's probably the most useful and the one you more than likely want to go to. This one's called switch. And the reason it's called switch is every time you give it an observable, it will throw out its previous subscription to whatever it had there and switch to the new observable you gave it. So this is useful in scenarios like your autocomplete, right? That's the classic RxJS example that you see in like literally every talk, except for this one, I won't do it. I'm sorry, Jeff. But yeah, you don't want to keep all those AJAX requests alive. You want to terminate them if you don't have any use for their value anymore. So to walk through this, it starts, you get observable A, it subscribes to it immediately because it hasn't subscribed to anything yet. A gives me a couple values, then I get observable B. When I get observable B, it actually is going to unsubscribe from A because I don't care about the values anymore. Then it subscribes to B, and I get a few values from it and forward those along. But then I get observable C, same thing happens. I don't care about the results of B anymore. I subscribe to C immediately, and I wait for C to complete before my resulting observable will complete. So this is a really, really useful operator, just generally useful, especially in single page apps. So switch strategy, just again, it's called switch because every observable you give it, it will switch to that observable and tear down the other one. It's useful for a lot of things, like especially if your teardown logic is doing something nice, like maybe it sends a network request to tell the server to tear down or something. But yeah, it will keep going until the very last one it received is complete and the source is complete. All right, so mapping and merging. So that's a lot of work. We've got map and then MergeAll, map and then CanCat all, map and then switch. You notice not switch all. That's because there are other operators, merge and CanCat, that work like array. So if you were to say A CanCat B or A CanCat B C, it's going to take all of those, put them in array, run them in an observable, and run CanCat all on them. And if you had some static collection of observables you were going to switch on, really it's just going to subscribe to the last one. So switch all doesn't make any sense, right? You'd never switch off of a static collection of observables. It would be, well, you could, just be silly. So these all actually have shorthand. So calling map MergeAll is the same as merge map. CanCat all variation is CanCat map, and then switch map. FlatMap is just merge map. We still have FlatMap in there. It's a common idiom in like Haskell and functional programming, so it's still in there. But the main operator is merge map, and the reason for that is it makes it easier for me to explain at this meetup. Oh, just no, in general, it makes it easier. Yeah, it's an alias. Thank you, Jay. So recapping the talk here is observables are just functions, operators are just functions. You've got your 3 merge strategies here, which everybody, like all the hands were raised whenever I asked that question. So I think that we've got that. However, I was contacted yesterday because Rob Wormald has, he double booked himself and he's literally on another continent right now. So I put together some bonus material. I get questions about this a lot. People are like, oh my God, hot versus cold observables. How do I know? Do I take its temperature? They don't know. It's really not about hot versus cold. It's really about active or inactive producers. So if the producer that has that is giving you values from your observable is active at the moment you subscribe or is inactive until you subscribe. So here's a cold observable. A cold observable looks like this. And the reason it's cold is because I'm actually creating the WebSocket when I subscribe to the observable. It's inside of the observable, right? So that every time I subscribe to the observable, it creates a new WebSocket and gets going. So if I was to subscribe to this 3 times, it's going to create 3 new WebSockets. So I don't know if you can catch that, but the very top line, that guy right there, that's where it's creating the WebSocket and getting things started. Now, if I was to make this hot, it's really as simple as just moving that WebSocket that was there outside of the observable. That's it. This is hot now. The WebSocket's already active before you subscribe to the observable, but there's one problem. You'll notice what I'm returning there. The first observable to complete is going to kill my WebSocket, so that's not good. We don't want that. So what do we do to fix that? Let's talk about making an observable hot. So I want to make an observable hot. You just give me any observable and I'm going to ensure that it's hot. So let's just say that my observable is this cold observable here, this one that's going to create a WebSocket, right? Well, to make it hot, what I need to do is I need to subscribe to it outside of an observable that I give you. So what I'm doing is I create a subject in the first line there, and then I use that subject and subscribe to my cold observable. And subjects work like this. Any value you pump into them, they emit as an observable. So it's just kind of a funnel. It's a way to wire it through. And then I return a new observable that subscribes to that subject when you subscribe to the observable. So what's going to happen is I've subscribed to that cold observable. It's active. It's doing whatever it's supposed to be doing and just pumping values into that subject. And then whenever you decide, or maybe you don't decide to subscribe to the returned observable, it's going to start getting values that are coming through that subject from your producer. I've moved the activation of the producer outside of the observable. It's exactly the same. So this again is the important bit. The cold observable is subscribed to outside of the observable that was returned. So what if I don't want to, I want to make it hot, but I don't want to like start it right away. I want to start it at some later point. Well, then we have publish connect. And this publishing and connecting actually exists in RxJS. This is a method for making a cold observable hot. But I just kind of want to show some a really simplified version of what it's doing. So it looks a lot like our other method, right? Our other make hot method. The only difference is that well, when I call this, just so we know how it works, I call publish on my source, I get this observable foo back. I subscribe to it, and it's not going to start getting any values yet because my producer isn't active until I call connect on it, right? So what I've done here is I've taken that cold observable subscribe that was right above where I was returning the observable before, and I've just moved it into a method that I've kind of monkey patched onto my published observable there. The idea is, again, I'm taking the activation of the producer out of the observable and moving it somewhere else. So that's all of the magic. It's really as simple as that. When I call connect, it calls subscribe and wires it up to the subject that is inside the thing that you're actually getting values through inside of the observable that's returned. So moving the activation of the producer outside of your observable. So just a quick recap of cold or hot versus cold. Observable is hot if the producer is activated outside of the subscription. It is cold if the producer is activated inside of the subscription. It's really all about the producer and not about the observable, whether or not it's hot. I mean, I guess it's a matter of opinion, but. And again, observables are just functions. That's all I've got. On Twitter, you can find me at Ben Lesh. On GitHub, I am blesh. I love getting questions on Twitter. I try to help everybody I can. My team is hiring. So my team is hiring a full stack developer. You get to work with myself and even better, Mr. Jay Phelps here and a lot of other really brilliant people. We work in the Netflix cloud. We do a lot of really cool data visualization. And if you're working full stack, that means you'd also be getting to work with a lot of really cool real-time Java and Node stuff off the Netflix cloud. So if you're interested in that, there's a link here. I'll be sure to publish the slides. And you can also email me resumes, whatever, with your interest. So that's it.
So my name is Alex Eagle. I work on the Angular team at Google, and I work a lot in TypeScript and our developer tooling and making you guys really productive, and really productive developers are happy developers. So I hope you guys are all happy, and I'll try to make you happier. I don't know if I can do it in 20 minutes, but I guess since Rob isn't here, I have a little extra time. All right. So developer productivity, I've been working on this for the last 6 years at Google. Wait, hold on, something's up here. I want to allow that. Okay, good job, Google Drive. Okay, developer productivity, for the last 6 years, I've worked in our continuous build system, our system that stores all of your test results, and our build system, all in, the internal ones at Google. And it's really cool that I'm on the Angular team now because I get a chance to do all of this stuff for the open source community. It's a big focus of Angular 2 to make everybody else more productive. So Angular 1 helped to make testing a real thing in the web, and Angular 2 is hoping to bring a lot of language features and language tooling that makes you more productive. So let's think about some things that could make you more productive. I know the thing that makes Victor the most productive. You saw his talk. He knows all this stuff cold. It's because he uses this keyboard with these perfect cherry clear key switches. Now I use cherry blue. I didn't even know about cherry clear until recently. So I suggest you guys upgrade to that if you want to be able to type the fastest. And also caffeinated beverages. Of course, we all take a couple of those every hour. But I can't really help you with those two. Maybe that'll be part of Angular 3. So let's talk about real things and stop being silly. That's not true. I'm not going to stop being silly. The fast development round trip that you get, so like instantly going from coding to your browser and back, or from coding to getting unit test results in the console. The ability to reason about your code. So we want your code to be maintainable in the long term. You need to be able to understand what it does. You want the framework in particular. You want the behavior of things like when events fire and how they percolate through the system. You want that to be predictable. And the thing that I want to talk about today, because I had to pick something for this amount of time, is helping you avoid spending hours debugging and how many mistakes the tooling can help you avoid. So getting into that topic, there's a whole sequence of events that happen between you typing on your cherry clear key switches and your users being delighted with your application, hopefully. And so we could find defects while we're coding, when we run our automated tests, later when we manually test. Maybe we have a canary that runs out there with some segment of the users. And each one of these things, as we go further down the list, is a bigger hit to your productivity if you find the defect at that time. And I think we've all seen examples of this, or we've sort of heard this this axiom in development, that while you're coding, it's the lowest amount of productivity hit because the compiler has a really fast turnaround. It gives you a red underline, hopefully right there in your IDE, so you know immediately after you make the mistake. The mistake is really fresh in this case. And as we go down the list, when you're unit testing, you might have to debug in your test, and the mistake might be something like an hour old. When you're manually testing, you might need to figure out how to reproduce this thing first. Then you have to redo the manual tests when you make the fix, and the mistake is even older, maybe a day. Canary, harder to find. You may have to cherry pick and do like release stuff, and the mistake might be a week old. And then if it's a production user, the mistake could be like a month old, and now like you have to stop whatever you're doing. And if you're good, you write a postmortem about like where this went wrong. The green one is awesome. Why is the green one so great? The compiler is producing warnings that you can fix really quickly because they're targeted at a certain spot in your source, as opposed to an error later in production, which might have no relation to like, where did this get caused? Where did this undefined reference come in? the compiler should appear everywhere. So for everybody in their editor, for everybody on their command line, everybody on your team shares this thing. And in particular, there's no warning blindness about things that the compiler reports, because we usually don't accept that we're going to just leave compiler errors in our code base when we check in. So what are some things that the compiler can help us find? And obviously, this being a talk about TypeScript, like the fact that we have this compiler at all means that we get certain benefits we would hope that we would for spending the extra time to put types in our code and running through a build chain that has to transpile our code. So one thing, obviously, if you have a syntax error, it tells you that. If you renamed something but you forgot one spot, it will tell you this identifier is not defined. And the type checker catches a lot of things, like if you pass the wrong data type to a method that wasn't what it expects. But there are a lot of less obvious things that a compiler can help us find. And as much as possible, I would love to find these errors at the top of this list when they were really fast to fix and they didn't hurt my productivity. What can we do to move some of these defects earlier? One class of errors that are easy to detect in the compiler is if you make a statement and it doesn't have a side effect, and then you do nothing with the return value. So a great example is string.trim. If I call that here on this code, expecting to trim those white spaces away from the letter A, it's not going to do anything. S.trim returns the result in the return value. It doesn't mutate the object that you called it on. This is always a mistake, and there are lots of APIs where it's a mistake to call this API and you throw away the return value. Another example is an expression somewhere in your code that you can logically reduce ahead of time to a simpler expression. So here I have a check not null helper where I expect you to pass me an object as the first parameter, and I check if that's truthy, and presumably I would return if it's truthy, and then I call it with the parameters in the wrong order. So now I'm saying check not null of a string literal, and if we look inside the implementation, we say, oh, a string literal is always truthy. This will always be true. So our check not null statement we could reduce ahead of time to simply a no-op. So we can know that that's a mistake also. How do we? So maybe your minds are starting to wander. It's late. You all just ate food. Maybe you're thinking like, oh, what kinds of things could I find in my code? What we have found, and I'll talk about our research in a little bit, is that the best way to find these things is empirically. We don't want to use. So this is a class of checks called static analysis, which has existed in computer science for a while. Static analysis just means if we look at your code but don't execute it, what kinds of things can we figure out about your code that might be useful for you? And the type checker is actually a form of static analysis that we are already using if you're using TypeScript. When we want to add more of those kinds of static analysis checks, the best way to do it is the things that waste you the most time. Ask yourself, could the compiler have caught this thing? And if you find one of those, I want to know. I'll put my contact info at the end. Tell me when you find these things. I would love to make these static analyses built into the toolchain in a way that can catch these mistakes before you spend a lot of time debugging. So we have some history with this. So I started this project called Errorprone, which is for Java. It's an extension to the compiler, which is kind of a hack because it doesn't have an extension API, which I hope we'll get in TypeScript soon. And in Google's own code base, we use this to find a lot of different kinds of mistakes. What's going to happen if I click a link right now? Am I going to pop it into bigger? So for example, check return value is something that we place on a method when we say it's illegal to ignore the return value here. So like for string.trim, we have put check return value on string.trim for Java. We also use this thing to show errors, to show warnings in code reviews, but obviously for warnings, there's this warning blindness problem. And what we really want to show you is mistakes that you just made. They have to be fresh. Only fresh mistakes are the things we want to point out because we know you can fix them quickly. So we have lots of bug patterns. If you are curious, you can check out errorprone.info. And we're writing a paper actually now about how we rolled out this form of static analysis to all of Google's Java code. And that paper has some good lessons that I'm hoping we can eventually use in TypeScript as well. So that's all kind of like future mumble bumble stuff. We don't have that in TypeScript today. Let's talk about some stuff we do have today, assuming that Matthias has finished cutting the release of Beta 7. Are you even working on it? What are you working on? Okay, so don't worry, I have this little white box at the bottom. You can't read it, but I'll have a link to my slides. But you can get a snapshot of Beta 7, which I'm sure will be released momentarily. So in Beta 7, we finally support TypeScript 1.8, which is currently in beta. So you can install TypeScript 1.8.0. And we're going to switch to some code and see what kinds of TypeScript 1.8 features we can use to find mistakes. So let's have a moment of silence and hope that the demo goes okay. Okay, so I've got this little app. Should I make this text bigger? Will it still fit on the screen? Okay, so this is a beard app. So Jeff currently uses a competing beard app for managing his beard and his trimming schedule. So I thought maybe I could make one. It turns out I had a lot of mistakes in here, and so I wasn't able to ship it for today's meetup. But it does have, it does have some interesting mistakes inside. Now, right now, all of these files are, there's no red underlining in this file, and then I have my beard trim component, which has this template like should you trim, and I'm using a blink tag because I have bad judgment, and it's only supported in older browsers, which I require if you use this beard app. Great, so everything is not red like it's supposed to be. And so if I open my TypeScript configuration file, the first thing you should notice here is this beautiful font. Thanks to Victor brought this up to our team. It's called, do you want to tell us about the font, Victor? Okay. Okay, yeah, talk to Victor afterwards if you want to use this font. It's called Operator. You can see that the italics is like cursive writing, so it's really cool. Not actually a productivity booster, though. I spent a lot of time distracted with this today. Okay, so let's talk about some new language features in TypeScript 1.8. So we can put comments in the tsconfig.json, which is nice. We can document why this option is turned off. This is really great for being able to link to your bug tracker when you have to switch an option that's weird and you want to turn it back later, so you can keep that attached. And we also have some static analysis options that are new. So allow unreachable code, I'm going to turn off. Allow unused labels, I'm going to turn off. I'm going to turn on no implicit any, no implicit returns, and no fall through cases in switch. And now bad things are going to happen to my application. Oh, and I forgot one thing, which is this pretty feature, which is new. So if I run this on the terminal now, is this big enough? Run TSC. So I'm going to run TSC in watch mode. So now I get errors in my application. And these are nicely colorized now and have line numbers and a snippet of the source. And if I switch back to Visual Studio Code and then I have to restart it because the TypeScript language services does not yet watch changes to the tsconfig.json file, but they're fixing that. And I go back to my beard app. Okay, some stuff is red now. Okay, so I accidentally pasted a link in here that I encourage you guys to visit, which is the What's New in TypeScript wiki page, which will catch you up on all the new language features. It was allowed here. I accidentally pasted it while I was really sleepy or something. And it's allowed previously because it starts with a label, HTTPS:/, so that doesn't belong here. All right, so now we have this experiment. So if the logged in user is Jeff, he uses this super fast beard growth ointment. And since I'm trying to get him as my first user, I wanted to make sure I had this feature to begin with. Obviously, this experiment is only turned on for him. And if we go to the beard trim file, we have some more red here. So let's see what the editor is telling us. This says fall through case in switch. So accidentally, I'm overwriting the result variable in my second case and I meant to do a break here and here. This one is saying my April Fool's feature that I added in a real hurry. That there's unreachable code here because we already returned the result. We can't ever possibly execute this line. So I think that was supposed to go there. Next, we have a getter function for the length of the beard. And the mistake here is that not all of the code paths return a value. So this is a little sneakier to catch in the code, but you can see I have a conditional here with the return. And what happens in JavaScript if you just fall out of a method without Jeff? That's correct. So we don't want that. So probably if the experiment, yeah, go ahead, help yourself. So I'll probably want to return something else there. And the last one is sneaky. So this is a new type system feature, or at least this method uses it. So this method uses parameterized types, which is to say that if I pass in something of a type, the type of the first argument will flow through the function and be the same as the return value. So if I pass in something of a certain type into this function, then the type checker knows that the result of the function is also of the type of the first thing. Yeah, Hans likes that. Oh, I'm sorry, I embarrassed you. It was worth it. Okay, so what it's telling us here is that this implicitly has an any type. and it's the index signature of this object. So an index signature is TypeScript's way of saying, what does it mean if I put square brackets on an object and just request stuff from it? Does it take strings or numbers? Either one of those is legal as a way to dereference things off of an object. And what kind of value does it return? I mean, does it return a string, or is it like your own object? And, or, you know, it's basically a cheap form of a map. And right now, I'm going to take advantage of the optional typing feature of TypeScript, where I don't care. And I'm going to tell it to just shut up about type checking right here. And that's fantastic. So don't forget, you're not required to type everything. There, you can always put an any on it. I'm hoping to get some Portlandia style t-shirts for us. I don't know if anybody's seen that. Nobody's laughing except Jeff. Okay, so everything is now green, but there are still 2 more mistakes, one of which was my mistake from earlier. So I'm using the moment library here, and I'm passing basically like when you should trim your beard if you're using the super fast ointment, and the answer is you should really trim every day. So it tells you at the end of the, oh, okay, well this is, yeah, you're not gonna use this app anyway. I give up. So today is not actually a good value to pass in here. The reason is that the typing here is string, and in TypeScript 1.8 we can give a better type here that constrains what this method is supposed to take, and you know, at some point hopefully they will add that. So the valid options here is day or month, and if I go back to my file, now I get an error that says that today is not assignable to a parameter that accepts a type of one of these 2 string literals. So that's pretty cool. That allows you to add more constrained typing so that the whole tool system can, the tool chain can help you more. So that was supposed to be day. And now there's one more mistake that's especially hard to find. And it's down here where I assign the beard dimensions. And I've used a Z here of 1,000 when you have the super fast ointment. But really this object up here has the X, Y, and Z are lowercase. So why is the tooling not helping me here? Like, why did this mistake go uncaught? Again, it's because I can tighten up my type bounds. So this assign method really is trying to say, I take a target T and a source U, and for every property that I find on the U, I should be able to put it into the T, which means that really the U is supposed to extend the T. And this is F-bound polymorphism, which is kind of technical, but it results in there being the right red squiggly here. That Z is not valid, and lowercase z should be. What did I do wrong? I got it in the wrong place. Yes, okay. Right. T should extend U because all of the properties of the source should be valid in the target. Okay, yeah, thank you for helping me program. It's good to have teammates who are always watching your every move. And now it compiles cleanly, so that's the end of the demo. And so next steps. So we're working with the TypeScript team to add extensibility points in the compiler, not just for the static analysis stuff I talked about, but also for like a build tool system, build chain, to be able to understand more things about TypeScript and Angular together, where, for example, the template URL points to a file, and that file should be understood by the build system, and we should be able to stitch that in without having to write like a separate build chain on top of that. And I'm hoping that we can use that API when it's available to add more of these kind of checks on top of what I just showed you in TypeScript 1.8, so we can make your lives even better and more productive. I'm finally done, and there's my email and tweeting, and I also made a link to these slides so you can find them. Why is my Twitter account Jake Herringbone? Well, so yeah, I was friends with this guy who's decided that he was going to go by Bobby Isosceles, and so he gave me this Twitter handle when I was in high school, and I didn't realize that I was going to be tweeting for work at some point, because like that doesn't make any sense. Yeah, so yeah, Bobby Isosceles. Way to go, Bobby Isosceles. Yeah. All right, that's it.
We've got another special event. At the Modern Web meetup last month, I gave a presentation, and part of the presentation, Alex read a love letter that I had written as like a metaphor to Angular2 component decorators. And Tracy thought she could do a better job of it. And so I've written a new love letter, and each of them is going to read it, and then we're going to gauge which one was better by audience reaction to it. Here is Tracy's reading.
All right, guys, I really want to win. Where did I meet this person? Was it Tinder match?
It's Civil War times, and they stayed at your inn.
Oh, okay. Civil War times, and they stayed at my inn. Okay.
Soldier.
I have to get in the mode. Okay. Dear Angular injector, thank you again for agreeing to configure my dependencies for me. As promised, I've provided an array of common providers needed in my application, which I intend to pass as the second argument to the bootstrap function alongside my root component. Included in my providers list is an observable of my love for Angular, which emits a new value every time I think fondly of Angular. I know I can trust you to take care of my providers and to instantiate and configure them each time a component asks for them. Some components may provide their own set of providers that are not included in my common providers array. In such cases, please feel free to configure and instantiate such providers as specified. Thank you in advance for your flexibility in such matters. Regretfully, I must attend to other matters now. Please do let me know if there's anything else I can do to support you. Lovingly yours.
Wow, great job. That's going to be hard to top. All right. You can listen. No, I don't know. What do you think? Do you want her to? Yeah, you have to listen to the headphones.
You don't have the rights to that.
You can watch the recording later.
It's amazing.
All right. Okay. She did a pretty good job, Alex.
Yeah.
And we'll do applause for both of them at the end. So you can give a courtesy clap after he does it, but that doesn't count until we do both. Okay. Ready? Are you ready? All right. Here we go. Should I keep this mic? Do this one. All right. Better effect. Wow. Good setup.
Dear Angular injector, thank you again for agreeing to configure my dependencies for me. As I've promised, I've provided an array of the common providers needed in my application, which I intend to pass as the second argument to the bootstrap function along with my root component, just like you like. Included in my providers list is an observable, which has my love for Angular inside. It emits a new value each time I think fondly of you, just like you like. I know I can trust you to take care of my providers and to instantiate and configure them each time a component asks for them. And some components may provide their own set of providers that are not included in my common providers array. And in such cases, just do what I want, okay? I don't want to have to explain this to you. I'm really tired. I have so much JavaScript fatigue. But your microsyntax is really cute. Thank you in advance for your flexibility in serving my needs. Regretfully, I have to go hang out with React. Let me know if there's anything else I can do to support you. Okay, my name's Alex. Thank you very much.
Okay. Okay, are we ready?
I'm nervous.
All right. Okay, first we'll do for Tracy, and I'll do the applause-o-meter with the arm. Okay, for Tracy. Okay, all right. Okay, good. Okay, now for Alex.
I feel very validated. Thank you.
Good job. Thanks you to both of our participants. Matthias, also from the Angular team, wanted to give a quick talk about Electron? Renderers, including Electron, I think. And then we'll have a panel with our speakers and some other folks from the core team and some more fun stuff.
Okay, this won't take too long. I just wanted to show you guys some stuff that me and Rob Wormald are working on, and that is having a different render your Angular application. So it's going to open up our first application here. One actually. Sorry. All right, so I have an application here that contains nothing more than just a simple collection of items, an image, a heading, and some other content. We also have the application code that's packed together with this, so there's nothing crazy going on here. Now, inside of my source, I have a canvas renderer. So I'm going to show what we can do with Angular 2 where we can extend the renderer. Now, this is experimental. The code for the renderer is going to change. And the reason why I'm talking about this is because tomorrow at NGNL, a friend of mine is going to talk about this in detail. So what I've done here is I created a canvas renderer. Oh, 1 second. So if we look in our app.ts code, we can see here that we've extended the Angular render. So I'm not going to go over the code in detail. I'm just going to show you the idea of how it works. So our canvas renderer code is hooking up into the DOM renderer, which renders the page. We've extended some of the methods. And in doing so, we hop into the canvas and we attempt to draw those elements on screen. So we're effectively taking the DOM structure of our application that Angular prints out and putting that into a canvas element. So let's see how this looks. I'm going to compile the application. And then I'm going to load it to a web server. And that basically took all that HTML code, rendered it for Angular, and then piped it into our custom renderer. So this would normally show up in a DOM, but I extended the renderer code and I added in the special printing capability of putting it into a canvas. Now this is a canvas image, and if I were to change the HTML code, then the canvas would update itself. So that's the first example of this. Let's take a look at something a little bit more useful, which is using Electron in our application. So this is a different application, and it's basically a calendar. So I'm going to show you what it looks like in web first. Okay. This is going to compile the application. It's going to open up in a browser, and we have a calendar for February. This is a simple Angular 2 application that's running on web. But if we change the renderer code, so if I could take a look, and instead of going into our web.ts file, which is effectively our app.ts file, we go into our desktop.txt. And in here, we're loading the Electron plugin. So right now, the plugin's still being developed. If you were to go to on GitHub Angular/Angular Electron, you would see the plugin in action. So we're loading in the bootstrap method. We're bootstrapping the application to Electron. So now when I run my preview command for desktop, it compiles the application, and it launches it in Electron. And this is Electron is a desktop. It's not a browser. It's like actually running your website as if it were a desktop application. And once Angular becomes more stable, once these plugins become better developed, you'll be able to switch the renderer, and you can have a different renderer render out your application. So that's the extent of the talk, and pay attention tomorrow for NGNL's talk about renderers in Angular.
Okay, so any questions? It can be general Angular questions or questions about talks tonight. No questions. Easy night.
I have a question. Why are you using Ember CLI?
I think Igor would be the one to best answer it. He and Stefan. So Ember CLI, it's a good product. So people like it in the community, and we saw how easy it was, and we said, yes, that's what we want. And Alex can answer, but so we saw they had a good model, and they had a lot of the same problems as us. And
yeah, and sorry, in particular, we were working on our own build system to make things fast and to get fast round trips, and Angular 2 is a pretty large code base. And so when we started with Ember CLI, we were using just a library inside of it called Broccoli, which is a build pipeline that's all about describing declaratively a set of transformations to be applied to your input file system to arrive at what you want your output file system that you serve to look like, and then be able to do just rebuild the necessary parts. Yeah, it's kind of distracting. Yes. So we wanted. So once we made this really fast round trip build system, we wanted to make that part of Angular CLI. And since Ember CLI developed Broccoli, I think that's part of where it came from.
I think one of the reasons I brought that up is because I always hear people saying, "Oh, Angular's using Ember is so funny," but I think it's awesome that the core teams like to collaborate.
Yeah,
So
and
I feel like
Stefan,
that's
who's
really
one of the
awesome.
main contributors on it, visited us last week. Spent the whole day at Igor's desk, which was kind of confusing for people actually.
It's really cool to see the core teams like working together instead of working against each other.
Agreed.
Any more questions? Oh, we have one over here and then another one over there.
For the reactive JavaScript, on the third strategy that you were describing, which was, I think, switch.
Yeah.
It was pretty interesting in the diagram that, like, as soon as you get a new observable active, you start ignoring the previous one. I don't know if there's any, like, are you responsible for the the observables that you're now ignoring, or does that become like a leak that, you know?
No, it actually will call the unsubscribe logic that's returned by the observable subscription. So it'll tear down any underlying resources with the observable as soon as it disposes of the previous one. Yeah.
Okay. All right. Thanks.
All right, we have another one over here.
I'm curious, what's your suggestion for the strategy to migrate from Angular 1 to Angular 2? You probably got asked a lot about this, but I'm curious, what's your experience or the strategy you think is best fit for general situation?
All right. So there are a couple of options. I think the main one has been ng upgrade. So you can nest Angular 1 and Angular 2 components in the same app and it works. So like bindings work and NDI works. So you can start slowly, maybe start with the leaf view applications and replace some leaf components with Angular 2 components, and then slowly move up and then replace chunks of the application with Angular 2. So that works, successfully.
Also the 1.5 upgrade.
Another one.
I was just wondering if any benefit to using Ember CLI with an Angular 1 application, or is it just Angular 2?
We haven't worked on anything to do with using Ember CLI for Angular 1. Yeah. So if you're using TypeScript for your Angular 1 app, you would want a fast build chain, and maybe Ember CLI is a good choice. I don't have any idea if somebody's tried that yet or not, but you could be the first.
Definitely, I've heard a lot of people in the community use Ember CLI for all their projects, not just Ember projects. So
one quick thing to add to the previous question also about the upgrade path is if you upgrade to Angular 1.5, that will get you part of the way there. So some of the features are backported. You can also upgrade to the new router, the component router in your Angular 1 app. So you can make incremental steps.
Hello, quick question. If I have a big application, I want to have my own plugin system. How can we achieve this in Angular 2? Any suggestion?
What system, sorry?
Did you say plugin system?
Yeah, its own plugin system for my application, so that new components can plug into like Eclipse, right? One example is like a dashboard. If
Okay, so I mean, like if you have something like a portal, yes, like you can define your components that you can plug in or register in your system, and then use something like dynamic component loader, which is the service we provide in Angular 2, to load these components into dynamically into dynamically and into areas of your app. So it's more like an architecture kind of question. I don't think it's a framework kind of question because the capabilities are there, so you should be able to do that. But how you architect it exactly, I don't think it's Angular specific.
But yeah, components are the key.
Components are the key. Yeah.
Components are everything.
Any more questions? Okay.
Hi. So about the gradual upgrade path you suggested, if I have a pretty big code base that is Angular 1 and I want to migrate to Angular 2, now Angular 2, one of the advantages of migrating is supposedly speed. If I take an Angular 1 code base and I do this gradual upgrade, will I get the speed advantage, or will I basically have Angular 1 performance, or will I just feel the difference with new code that has been created in Angular 2? How will it live when I do gradual migration?
So there are various things that contribute to the speed of Angular 2. One thing in particular is that the amount of times we touch the DOM. We have the separation between the component and the renderer, just like I mentioned. So if you think about the renderer, it's receiving simple instructions to say, update this DOM, update this code. So if you follow the structure of Angular 2, you'll have an upgrade there. Another thing which another member of our team is working on is this notion of a compile step, so that you can compile parts of your application so that they're parsed and figured out ahead of time, so that when you load your application, you have code-generated code, which is designed to make the application run very fast. And while doing so, we can actually remove a lot of the framework code that Angular has, so you're downloading a smaller application.
Like just to make it clear that like if you have a component, Angular 2 component, Angular 1 application, we are going to use the Angular 2 compiler to compile this component, and we're going to run Angular 2 change detection to detect changes. So that component will be fast. Yes, the rest of your application, if it's Angular 1, will remain Angular 1 application. It won't automatically get faster, but whatever you migrate will be Angular 2 fast. So it won't be Angular 1 slow. Or not like it's slow or whatever, you know. But so. Yeah.
But there is a little bit more of a load time cost because you have two libraries being loaded in the interim.
Hello. So I have two questions. One is for the Angular and one is for the RxJS. So maybe I can start with the RxJS. So is this the right time to have a comparison of RxJS with React Redux? Because what I see, because you was talking about more of observables and all that.
Yeah, so Redux and RxJS are orthogonal, really. So RxJS is observables, which I went over today, and a lot of operators on observables. You can actually build a Redux pattern, and I've actually done that at Netflix, and I'm probably going to open source it soon with RxJS. But one is a state management pattern, and the other one is a functional programming pattern. And of course, you can use that to manage state, but they're a bit different.
But still, when you're saying that, one is the state pattern, I think, which is Redux. And,
right.
And if you're talking about the RxJS, it is more into functional programming. But I think at the end, both have the same kind of functionality because at the end, they tries to notify, whoever tries to get into the stack.
Sure. Yeah, they do. I mean, they do have they can be used in a similar way. But again, an observable in RxJS is so primitive that, I mean, you could build any sort of state management system out of it. It wouldn't necessarily have to be a Redux pattern. You could just only use observables and have that manage your state management like all the way up to your parent and then back down to all the children. But I mean, at the end of the day, one is again a state management pattern. The other one's an async primitive, or it's not even always async, but a primitive type in JavaScript. So
sure, thanks. So one more for this Angular. So I think if I'm not wrong, so in Angular 2.0, I think there is no provision of two-way binding.
Okay, so can I add to the first question first, because I think it's very interesting.
Yeah, sure.
So I agree with Ben that the concerns are orthogonal, but we need to be very careful when we talk about Redux to define what exactly we mean, because Redux can be thought of in a very abstract way as a way to push state outside of your app and manage it somewhere else. And in this case, you can totally use Rx to do that, or whatever, implement something like this. But if you mean Redux in a way like Dan Abramov does it, so it has to be synchronous, for example. And then if it has to be synchronous and has to do all the stuff that Redux does right now, then the benefits of using Rx to do that, you don't take full advantage of the library. About two-way bindings, so we don't have two-way bindings in the sense that Angular 1 has them, but we have a way to implement a two-way binding behavior using a property binding and an event binding. So you put a square bracket and a paren, and I call it a banana in a box because it looks like a banana in a box, and it sounds really funny. So when you use this banana in a box syntax, you have a two-way binding behavior in Angular 2, but it's a lot more predictable and has well-defined semantics. So you can still reason about your code in the same way. The tooling can still work the same way it works right now. But it kind of sort of is screened, super hard, it's a two-way binding.
Maybe I can say that we can use two-way binding using RxJS.
Can you clarify your question? What do you mean by using two-way bindings with RxJS?
Yeah, so we have RxJS, right? So can we use or can we leverage the the implementation of RxJS to implement two-way binding?
Okay, so in Angular 2, you can integrate with RxJS by binding observables to templates by using, for example, an async pipe. But in this case, it's fundamentally a one-way binding because you consume a value that observable provides and you pass it down to a component. I mean, in theory, one can imagine using something like subject maybe and like doing some sort of, but I don't see an advantage in doing that.
Thank you.
In terms of moving to Angular 2, if you have like a team and you're charged with the responsibility of figuring out what and how efficient that is and whether you should do that, what are the you guys in your experience? What are the pain points that it solves, and what are the pain points that it kind of leaves unsolved or that get worse? And net, if you're going from Angular 1 to Angular 2, like why would you go for Angular 2 considering all the the learning curve and all the other factors? And of course, if you're learning something new, that's one thing. But if you want to talk about that, like what's the pain point analysis between those two?
I'll give my perspective anyway. We wanted to make a lot of things faster. Like we wanted to change detection and DOM manipulation to be a lot faster, and it is. Before we wrote Angular 2, we made a tool to measure these things better than micro benchmarks could, and we used that to guide us and to make sure that we're not regressing on performance for common use cases. We actually, like every commit that we commit to Angular runs against the suite of benchmarks in a calibrated environment internally, and so we make sure that it's always the same or better when we're committing. And this is like we're not the only people looking at it. Like teams inside Google look at this, and if we regress, then they let us know, and it's a high priority for us to fix it. So performance is much better. There are benchmarks out there on the web that show the performance of Angular 2. I don't know, is like that DBMon. I don't know how good those benchmarks look, like the quality of those benchmarks, but that's a good place to look. And I think we may publish some numbers of our own benchmarks. So performance was one thing. Developer productivity on big teams was another, like helping avoid common mistakes that big teams would make when they would step on each other's toes. And like somebody would register a directive somewhere and you would accidentally use it or something, or just lots of things where there was a global mutable state that somebody would manipulate something from some part of their application because it happened to run, and then it's affecting behavior somewhere else. Like these kinds of things are motivations for why things are more explicit in Angular 2. Would you like to add?
Yeah, so I have a general observation, which is that the amount that you want to invest in your current in whatever software you're working on depends on how long the lifespan of that software is expected to be and how many more changes you need to make to it. So very much like unit testing is an investment that you would make in your code, and that investment, it costs you something to put that in, and over the lifetime of the application, it saves you some mistakes, and it allows you to more reliably deliver the application. So. In one extreme, if you didn't really need to touch this app anymore, then you should just leave it in Angular 1. And if you have if the team is growing and this application needs to be maintained for a few more years, you'll get more return for, the investment in going through the upgrade process.
So what would that point be as a guesstimate, like something that?
You want to answer the follow-up? Yeah, 10, 42.
Heuristic.
So, yeah, I guess we have yet to migrate the big Angular applications at Google from Angular 1 to Angular 2, and we're going to learn a lot more from that. And I know that we're planning to give more guidance in this area as we do those, which we're hoping to start later this quarter once we have a stable version using TypeScript for Googlers to use. The big apps that we've launched so far on Angular 2 were rewrites, so we didn't get the experience of the upgrade yet. We're working with a couple of internal customers to pilot NG upgrade and get more experience, dogfooding it and doing that process ourselves. So I think we'll have better guidance soon. As far as like how much cost is there, how much were we able to save in the long term.
So some final things which will give you more motivation to have a team upgrade to Angular 2 is the tooling around building the web applications is a lot better. If you think about TypeScript, you have type checking capabilities and linting and so on. But also for HTML and CSS, we have these built into Angular. So Angular 2 has an HTML parser that parses the HTML code to see if it's valid and makes sense, and all the bindings, all the variables are there. And soon we'll have one for CSS built into Angular. It will tell you if certain styles behave in certain ways and if this CSS is invalid. So if you think about having a large team, people all have different coding styles, they make mistakes, you'll have a faster feedback cycle with Angular 2 compared to Angular 1, unless you put a bunch of tools into Angular 1 that do this for you. We do that in runtime when you're developing the website, and then if you run the compile step, which will optimize the website, do all the hard work for you during build time, that's also a capability.
So I have a question here. So I think that would be for Ben because it's about RxJS. Well, given that Angular 1 doesn't have async pipe, do you think it makes sense to use RxJS in Angular 1 app, or what would be your recommendation?
Yeah, you can totally use it. So there's a variety of ways. You could essentially implement your own pipe as a directive or something where the directive, whenever the directive executed its linking function, would subscribe to your observable, and then you would have to make sure to call a ticket scope and subscribe to $destroy and unsubscribe from that observable. So you could make a directive that did essentially what async pipe does with observable, roughly speaking, and have it pull values out. I've seen it. I've done it before. There's a few helper libraries out there for Angular 1 and RxJS 4, not 5. But the porting for that shouldn't be terribly hard. But yeah, it's totally, you can use it in anything. We use it in Node. We use it in Angular 1 React. So we've used it in Ember. So it's definitely something you can use in Angular 1.
Thank you. Oh yeah, time for one more question. Maybe two more.
Okay, so I'm a little behind in Angular 2, but I'm curious of the state of ng-animate because I was pretty excited about it. But
Okay, so ng-animate's something I work on primarily on Angular 2. I also work on it in Angular 1. And right now it's still being developed, and the goal is to have it developed when Angular 1 reaches stable. So for the next 1 or 2 months, like ng-animate will grow to become more and more stable. The approach in which it animates a website is much different. If you are interested, I can show you a design doc which goes over all the details about it. But the general idea is that instead of having a bunch of global styles which you use, you have a style sheet on a component, and then you have first class access to the CSS code. You're like, all right, take this class, animate it across all these elements and stagger it. And it allows for a much more comprehensive API of mixing dynamic styling and interaction support. There's a lot of really cool things in there, and it's much more performant compared to Angular 1 because it uses the web animation API if it's supported by the browser. And then if you use a polyfill, you have full scrubbing support. And all of the things that slow down websites when it comes to detecting CSS is handled within this precompile build step. So we can talk after. I'll send you a design doc.
Does it use observables? Can I compose my observable into an animation?
Right now, there's just basic promise support, but I do have a method called subscribe in the code, if that makes you feel better. But yes, the goal is to have this idea of mixing observables with an animation, so you can pause something and incorporate other user-driven events. So we should talk about that.
It's okay. You can wrap a promise with an observable. I forgive you.
I'm just curious about dependency injection. I understood that in Angular 1 we were using the string notation to defeat the minifiers and the obfuscation tools. So you could still inject the right dependency. But if you're using these types, I haven't used TypeScript, so I don't know how it would work if you're actually trying to minify or obfuscate your code.
No, but like when we're using types, we're using the runtime values. So like functions and classes. Don't think TypeScript, you know. like we show examples on TypeScript, but it's the same in ES6 or ES5. So we're basically using pointers to functions instead, yes? So you don't have any issues with unification because it's the same pointer in two places, yes? So you don't have the same like string or whatever field. Like it's the same object in two places. So if it's going to be minified to whatnot, it will still be the same object that you point to. So yeah, it will still work.
Okay, all right, thanks.
And you don't have to use types, just to make it clear that by default we rely on types because it's convenient and it's usually what you want. But if you have a weird, or not a weird use case, an interesting use case, you can, or whatever, you know, like I do it all the time myself. So you can use like strings, so like any object, you know, type is just the default that we use.